Welcome back, dear students, to the tetrahedron chemistry classes. So in today's class I am going to solve a numerical based on the electrochemistry, and this question was asked in the BTech first semester in the engineering chemistry examination of your Uttarakhand Technical University examination, right? So it was the examination of 2026. So it is the latest question, okay? And the value of the question was 5 marks, right? And question is quite straightforward. It's straightforward and simple, but you need to write all the things which has been asked in the question, like half cell reactions, complete cell reactions, and then the EMF of the cell. Okay, so how we can approach for this particular problem? First of all, you need to check the electrode potentials given. So what is the question? First of all, you need to check. You have been given this particular electrochemical cell, which forms by the combination of the aluminium and the copper, and the concentration of aluminium ion and the cupric ions are same, and the standard electrode potential for aluminium is given as negative 1.16 volt. However, this is looking like a typographical error, because the exact value or the correct value for correct value of standard electrode potential for aluminium ion is negative 1.66 volt. But we'll solve the question according to the value given in the question. And for the cupric ions, the standard electrode potential is given as 0.34 volt. Okay, so first of all, you need to know this value of electrode potential is the higher value. Okay, and I already told you in the semester class, during the semester classes, whenever you have the higher value of the reduction potential, I am writing Rp, then it will form your cathode half cell. Okay, cathode half cell, that means the reaction which will take place here, the reaction would be your cathode half reaction. So CHR I am writing for the cathode half reaction, CHC I am writing for the cathode half cell. Similarly, this value is the lower value for aluminium ion. Okay, and whenever the value of the reduction potential is lower in the combination of the redox reaction, then it will undergo your oxidation half reaction. Okay, and this is basically your oxidation half cell, OHC I am writing, and the reaction which will occur here, that will be your oxidation half reaction. Okay, so for oxidation half reaction, what you will do, you will write aluminium ion. Okay, and these aluminium ion will lose 3 moles of the electrons, and it will form the aluminium 3 positive ion. Okay, so this is oxidation half reaction. Okay, and then you are having reduction half reaction, where your cupric ion will consume 2 moles of the electrons and gets deposits on the electrode as solid copper. So this is your reduction half reaction. Okay, because in the first case your oxidation state of aluminium was 0, and it is undergoing it has increased its oxidation number by the 3 unit, and you know according to the modern definition, increase in the oxidation number is the oxidation. That's why it is oxidation half reaction. And here your copper has decreased its oxidation number from +2 to 0. That means reduction in the oxidation number, it is actually your reduction reaction. So these are the two half reactions. Okay, now you need to write the complete cell reactions, and for complete cell reaction you need to, so what you will do here, you can see here in the complete cell reaction, we need to cancel out these electrons. So how we can cancel out these electrons? It is not possible in the current scenario, but when we multiply this particular equation by 2 and the second reaction by 3, then they become equals. So what we will do, we will multiply this equation by 2, and this will multiply by 3. So what will happen? 2 ones are 2, and now you know this 2 when multiplied with this 3, it will become 6. So now it is 6, and this is 2. Now second reaction will multiply with 3, so 3 of the cupric ion, again they will become 6, and then 3. So this is the reaction after the multiplication. Okay, now we'll remove this, and then we'll go for the complete reaction. So what will happen here? Your 6 electrons gets cancelled, and you have the complete cell reaction, which will be your 2 of aluminium reacting with the 3 of cupric ions, forming 2 of the aluminium ions. Okay, and plus 3 of the copper. Okay, so this is your complete cell reaction. Okay, full cell reaction. So I'm writing complete cell reaction. Okay, now you need to calculate the EMF of the cell, and for the calculation of the EMF of the cell, you need to use the Nast equation. So your Nast equation is, so I'm deleting this part because I need some space. So I'll write here Nast equation. Nast equation is E cell equals to E standard cell negative of 0.0591 over N, number of moles of the electrons, log of oxidized form of the metal divided by reduced form. This is how we can write. So how we can solve it? So E cell equals to E standard cell. E standard cells, what is E standard cell? E standard cell is ER minus EL. Okay. So what is ER minus EL? E cathode minus E anode in the standard form basically. So it is standard. And the copper half cell or the cathode half cell, the value is 0.34 volt. So we'll write 0.34 negative and negative of 1.16. This will give you negative of 1.16 volt. If you solve this, so they will add together and it will give you 1.5 volt, because this negative will become positive, and 1.16 when added to the 0.34, it will give you the 1.5 volt. Okay, this much we have done now. So now what we can do, we can solve it further. So this is basically your E cell equals to 1.5 volt negative 0.0591 over 6, because 6 electrons were involved in the balance equation. And then you will write the log concentration of your oxidized form. Oxidized form basically the aluminum ion, because the aluminum undergoes oxidation. Okay, and the concentration of the aluminum is 0.01. 0.01, and you need to raise this particular power by 2. Okay, by 2. Why actually I have raised this power by 2? Because this stoichiometric coefficient after the multiplication of the after the multiplication of equation by 2, basically this aluminum ions are 2 times more. So whatever the stoichiometric coefficient is there in the balanced reaction, that value has to increased in the expression. That's why 0.01 power 2, and this should be divided by 0.01 divided by power 3. Okay, this much you have done. If you solve it further, 1.5 minus 0.00985. When you divide this 0.0591 by 6, this will give you this particular value, which I have already calculated in my notes. Square of 0.01 is 0.123 and 4. This one divided by cube of 0.01 is and 5. Please, it is very important to note that however in the examination your calculators are allowed, but you need to calculate by your own as well. Okay, so the square of this one is this, and the cube of 0.01 is this one. This is very important. Okay, 1.5 minus 0.00985 log of, see earlier this one was your 10 raised the power minus 4. We can write this 0.0001 as 10 is the power minus 4, and this we can write as 10 is the power minus 6. Okay, we can write like that. Why? Because after decimal here 1, 2, 3, 4, 5, 6 digits are there, so we can write it as 10 is the power minus 6. So what will finally you will have? So this equation can be further written as 1.5 minus 0.00985 log of 10 is the power minus 4 plus 6, 1.5 negative 0.00985 log of 10 is the power 2, and you know this can be further written as 1.5 negative 0.00985 log of 100, and this can be written as 1.5 minus 0.00985 into 2, because log 100 equals to 2. And if you solve this, then you will find the value is 1.5 minus 2 times. When you multiplied it by 2 times, then this will become 0.0197, and your final answer would be 1.14803 volt. So this is the EMF of the cell. This is the correct answer.